So this is the oscilloscope, this is the function generator, and this is the multimeter. This is the multimeter that we use to measure the resistance and the voltage. This is the on-off button. And we connect two banana cables to these 2 points. This is to measure the resistance. And here's an example. And in the simple exercise, we're using a 56 ohm. So this is the resistor. It's a 4-color band. The first band is green, the second band is blue, the third band is black, and the fourth band is gold. This resistor has a resistance of a 56 times 10 to 0 ohms, which is a 56. Let's verify this using the multimeter. So here's to verify the resistance using the multimeter. So connect the two sides of the resistors. And then press this button to measure the resistance. And it shows 55.9, which is close to 56. So this is the second resistor we're using. The first band is brown, the second band is red, the third band is brown, the fourth band is gold. So overall it's 120 ohms. And let's check this on the multimeter. It's 118.5, close to 120 ohms. This is the function generator, and this is the on-off button. So here's the sine wave, the square wave, the ramp, the pulse, the noise, and here's an arbitrary signal. In this exercise, we want a sine wave and the frequency to be at 10K. So to set the frequency, we can type it here, just the 10. This is millihertz, this is hertz, and this is kilohertz. Or we can use this to set the frequency, and we can go 1 digit here, one more thing. We said that we need to set every time we use the function generator. So the first is press on utility, output setup, change it from low to high Z, and then done. Now to set the amplitude, we want a 2 peak to peak using the pad, this keypad here, 2, and then this is the peak to peak. This is the T connector. We use the T connector to connect the output from the function generator to the oscilloscope using a BNC to BNC cable. This is the BNC to BNC cable. We also use the BNC to banana cable to connect the output from the function generator to the breadboard. Now we connect the output from the function generator to the oscilloscope on channel 1. And here's channel 1. And we also use a 10 to 1 probe, and this is the 10 to 1 probe. And you can notice here that it's 10 to 1 passive probe to channel 2. So once it's on, we need to check the ratio for channel 1 and channel 2. So for the BNC to BNC cable, the ratio should be 1 to 1. The BNC cable is connected to channel 1, and this is for channel 1, so the ratio should be 1 to 1. For channel 2, channel 2 is connected to the 10 to 1 probe, so channel 2 should be 10 to 1. Now we need to change and to correct the ratio of channel 1. How to do this? We first need to press on channel 1 and then probe, and then probe. It shows 10 to 1, and whenever we see this sign, we use this knob to change the value. Notice here, now it's 10 to 1, 5 to 1, 1 to 1. Second thing that we need to measure the peak to peak, the frequency for both channel 1 and channel 2. So how to add the measurement? Here we find the measurement key, press on measurement, and we notice that we have old measurements. So first we need to clear all the old measurements. So clear measurements, and then clear all. Then to add new measurements, select the source. Now it's source 1. Select the type. It's on peak to peak, maximum, minimum, amplitude. So we need the peak to peak, and we can then add measurement. So now peak to peak for channel 1, and then we need the frequency for channel 1. And as I said, whenever you see this sign, you use this knob to change the value. So again, we need the frequency, then add measurement. So now we have the frequency and peak to peak for channel 1. We want the frequency and peak to peak for channel 2. So change the source from channel 1 to channel 2. Then the type, frequency, add measurement. So now it's frequency for channel 2. We also need the peak to peak for channel 2. Peak to peak, add measurement for channel 2. Now we have the frequency and peak to peak for both channel 1 and channel 2. So here's the breadboard, and this is the circuit that we are going to build on the breadboard. So we're using a 56 ohms and a 120 ohms, and then we're getting a sine wave from the function generator, and we want to display the output across the 120 ohms on the oscilloscope. So let's build the circuit. So as we said that we'll be using the blue rail as the ground. So we are using two devices, the function generator and the BNC the BNC to banana cable is connected to the function generator. So this is the signal side, and this is the ground side. So let's connect the ground to the blue rail, and you know that all these points are connected together. So any point here is connected to the ground of the function generator. Again, this is the 10 to 1 probe, so we need to connect the ground to the ground of the breadboard and the ground of the function generator. Now let's build the circuit. So this is the 56 ohms. You know that all these vertical points are connected together, and this side is not connected to this side. So if you connect this resistor this way, then both ends of the resistor are connected to the same point, and this is wrong. This is wrong because both ends of the resistor are connected to the same point. So the 56 should be connected this way. And then it's in series with the 120 ohms. Here's the 120. We can do this. Now these 2 points are connected together, and this side is not connected to this side. So this is right. Here one end of the 120 is connected to the ground. So this side should be connected to the ground. Now this is the input from the function generator, and it should be connected to the 56 ohms. And the output across the 120 ohms is connected to the 10-to-1 probe. Now this is the circuit. Again, this is the input from the function generator. One side is connected to the 56 ohms. This is the 56 ohms, and this is the side of the function generator. And then the other side is connected to the ground. And then the 56 ohms is connected to the 120 ohms. This is the 56 and this is the 120. Then the 120 is connected to the ground. The 120 is connected to the ground. Then the 10-to-1 probe is connected to the 120 ohms. So one side is connected to the 120 ohms and the other side to the ground. Now the circuit is done. So now let's apply the signal from the function generator. Just press the output, and then on the oscilloscope, let's press the auto scale. Now the yellow one is for channel 1, the green waveform is for channel 2. So for channel 1, so now this is the output. Channel 1 is connected to the function generator, and the function generator provides 2 peak-to-peak, but here peak-to-peak one is 1.57. So we need to increase the amplitude on the function generator until it's exactly 2 peak-to-peak on the oscilloscope. So we can use this to increase the amplitude. So now the amplitude or the peak-to-peak one is exactly 2, and the peak-to-peak 2 is 1.31 volts. So the output across the 120 ohm is 1.36, and you can verify this by calculating the V output using the voltage divider. So V output equals V input times 120 divided by 120 plus 56.